Hello, my name is Leonard, and I will talk about my individual project 2 for the data engineering course. The requirements for this project are to convert a Python code to a Rust code. So this project has both of them, but the main aim of having the Python in here is to test the speed between Rust executions and Python executions. We are supposed to have an SQL database to store information, and then the final output should be an optimized executable, Rust executable. We have to get GitHub actions for CI/CD for both of them, and then add a video to the project, and that's what I'm doing now. So I'll quickly talk about the structure of the code of the project. There are two workflows, GitHub workflows. So this for Python, and what it does is to install everything, including the requirement, format with black, length with rough, do the testing, and then run the speed test. So the Python speed test, the Rust speed test are both run during the CI/CD. For the Rust, the workflow is to do checking, formatting, testing, building, and then deploying. After that, I do the speed test. So a few quick notes. I'm using this option here to ensure that only one thread runs at a time. And this is important to me because I want the test to be executed in a particular order. By default, cargo tests will run things in parallel. So if I allow it to do that, then there could be a situation where one test, which is supposed to read some data, starts reading the data when the data has not been put there. So the order is important for my test. I use a no capture option here to prevent the test, which by default will not send any information to displays or files to IO to send them. I don't want it to not send them. So I put this option there so that it doesn't capture them. And this is because during the execution of the test, I write information to file. So I need it to send the information to IO, i.e. file, without capturing them. And then there's a Python code. The structure has mylib, which is a library, and then the main file here, and the log information is written here during test. The main function is to move data from CSV file to an SQLite database, and in the process transform the data. The requirement has all the dependencies in here for installation during CI. I'll move on to the Rust. The Rust has the structure. The source, mylib. Mylib is a module. Then these, except this, are the submodules. So the idea is to have this file, mod.rs, inside mylib. Inside mod.rs, we write the submodules names in there so that CRUD, extract, transform, util become submodules of mylib module, so that you could do mylib colon colon one submodule like crude colon colon then a function inside the submodule. One other option would have been I could have put another file at the same level as mylab and call it mylab.arrays and then put the same information in there to serve the same purpose. There's this lib file which exposes all the modules in the source folder. So we have to list mylab in here in the lib.arrays. Then there's a main, this is where the CLI is done. The commands are all here. Read one, save, read all, delete, update, load, and then the final one that's most interesting to me is the speed test. We also have extract here. For speed test, this is similar to what Python also does. I'll show you the Python speed test, which is also in the main. So this is a procedure. First, log the server time, pick the time, execute the transformation. So for the test, all we are doing is moving data from a CSV, transforming it, and then saving it into an SQLite database. And this is the same thing that both Python and Rust will do. Reading from the same file, but saving to different files. So there's no wait time in case they ever do it at the same time. But that's highly unlikely that they will do it at the same time because this is done during CI and they happen at different times. The Rust normally takes longer at CI because it has to build everything up. So at the end, we do the subtraction to get the time taken, and then we save that to the log file. We save again the current server time, and then we put a separator at the beneath that so that the next test can easily be differentiated. So I'll just go back to the main.rs and show you it's basically the same thing here. We log the server time, take the current time, execute, take the time elapsed, save the time elapsed, save the server time, and then that's it. Put a separator here too. So I talked about the source folder already. Now to the target folder. This is where all the executables go. So we have two types of executables, the debug and the release. The debug has all the symbols necessary for debugging, but it's not optimized. The file is here. There's a final file, but these are some of the things that it needs to get to the final file. The release is here. The difference is that the release has all the debug information stripped out of it and everything is optimized. So it's not really good for debugging, but it's optimized to run fast, to do things more efficiently. The next folder is a test folder. In order to do integration tests, it's necessary to have this folder tests at the same level as source. And that's a requirement of Rust. And then it will run anything that is annotated in it as test. The main tests that are done here, I'll talk about the crude tests that are done here. Read one data, and then assert that the fifth column is 16.4. For reading of all the records in the table, we read everything from air quality table, and assert that it's 18,016 records. For updating, we are going to update the same record we just saved. So we read it and we assert that the second column should have the value Lancaster. Then we change it with the update function to convert it to Duke. So Lancaster now becomes Duke. Then we read it again and assert that this time the second column is Duke. For deletion, we go ahead and read the same record. We assert that it is there. We go ahead to delete it and then assert that it's no more there after reading. And there's a utility function to read the columns of a table, and then we assert that the columns of the air quality table is 6. There's a file that is extracted, there's a file that is loaded. Then for the speed test, all of them pull the data from the same file, from the same CSV, and save to different files. They save the results to this .md file. So we can see that 3 pairs of tests were run, and you can easily see the result. So basically, this is the overview of the code, and I have some examples for running the Rust application and then modified accordingly to suit the purpose of any particular use. Thank you very much.